Hi, this demo video shows how to factor type 2 general quadratic trinomials. As mentioned in the previous lesson, we can write general trinomials this way. This is the general form: ax squared plus bx plus c. All right, that's how a general trinomial would look like. Now, if a is equal to 1, that means it doesn't show in the equation itself. You don't see anything there. If it's 1, it doesn't have to be written. Now, if a is equal to 1, that means it belongs to type 1. And we've already discussed this in a previous lesson, how to factor type 1 general trinomials. Now, if a is not equal to 1, then it is a type 2 general trinomial. And that is the topic of this video. How to factor type 2 general quadratic trinomials. All right, let's start with the first example. Let me write down the first example. We have 6x squared plus 26x plus 28 plus 28. All right, so this is the first thing that you have to make sure of, that your trinomial is arranged in this order. X squared comes first, and then x, and then the constant. If it's already in that order, then you can start first looking for the greatest common factor. Is there a greatest common factor or a common monomial factor? Let's see. Well, all coefficients can be divided by 2. We'll factor it out first. So let's factor out 2 and rewrite the terms of the trinomial as 3x squared plus 13x plus 14. All right. Now, the next thing that we have to do is apply the AC test. So that means we multiply A and C, the values of the A and C. So let's multiply. So this is called the AC test. We multiply the values of A and see if it will pass the test. Let's see, 3 times 14 is 42. Now the idea is this. Can we find factors of 42 whose sum is 13? All right. Just like in type 1, the operation that we apply on the factors will be determined by the sign of the third term. If this is plus, then we add the factors. If this is minus, we subtract the factors. And our goal is to get the middle term. All right, let's see if we can factor 42 and get a sum of 13. So we're doing this systematically to make sure that we don't omit any factors. 1 and 42 add up to 43, so that's not the one we're looking for. And then 2 times 21, that adds up to 23. We haven't found it yet. Now, is this divisible by 3? So remember how to test for divisibility by 3. You add the you add the digits. If the digits add up to a number which can be divided by 3, then the number itself is divisible by 3. So that means 42 is divisible by 3. 4 plus 2 is 6. And that can be divided by 3. So let's look for the partner. This will be 1, and that will be 4. 3 plus 14 adds up to 17. All right, that's not the one we're looking for. Now, can it be divided by 4? No. By 5? No. By 6? All right. The partner is 7. Now, we cannot find any more factors in between these two numbers. So, if this doesn't work, then we cannot factor this particular problem. But if it works, then we can apply the process that's described here. This is actually factoring by grouping. So 6 plus 7 is 13. So it's correct. We can use these numbers. The signs that we assign to both numbers will come from the middle term. Remember in our previous discussion on type 1 quadratic trinomials, if we do addition, then the signs are alike. It's either both plus or both minus. And that will be determined by the middle term. Since the middle term is plus, both of them are plus. Now, this is the process. We rewrite the expression. So we just copy the first term, but we have to split the middle term into two parts. 6x plus 7x. That came from the factors that we derived here. Notice that if you add 6x plus 7x, you get 13x. So we haven't really changed the value of the expression. All we did was we split the middle term into two terms. The next step is we group the first two terms together and the last two terms together. And then we factor the GCF for each pair. For the first one, our GCF will be 3. By the way, this whole thing will have to be multiplied by 2, the GCF that we had earlier. All right. Just so that we don't forget it, let's write it down here. All right, we're factoring out from the first two pairs, from the first pair of terms, we're factoring out 3x. And then we rewrite the two terms as x plus 6 divided by 3 is 2. The x is already out, so that's taken care of. Plus, now the GCF for the second pair is 7. Let's factor out 7. And then we have x plus 2. Now you'll notice that the binomial, these binomials are the same. It's a common binomial, so we can factor it out. All right. Let's factor out the binomial and put these two together. So we put this and this together. Let's do that. All right. 3x plus 7. And then the binomial, which we're factoring out, is x plus 2. All right. So these are the factors. These are the factors of the original trinomial. So it's done. Now the process will be very similar for the next 3 examples. I'll give one example for each, depending on the sign here. The next one that we'll discuss will have a minus here and a plus here in the third term. All right, here's the problem. We have 12. Wait, I change colors. I'm gonna use this one. So we have 12 a squared minus 25a plus 12. So the difference between this and the previous problem is the middle term is now negative instead of positive. But the third term is still positive. So that means uh, when we're breaking up the factors of AC, then we'll have to find the sum of the factors. All right, is there a GCF? There's none. So we go straight to our AC test. So our AC will be, the value of AC will be 12 times 12. 12 times 12, so that's 144. So this is what we're going to break up, 144. So we'll break it up into two factors, and we're looking for a sum, which is 25. All right, we're looking for a sum because the third term is positive. All right, so let's break it up into 144, but that sum is 145, so that's not the one we're looking for. 2 and 72, which adds up to 74, so that's not the one either. 3 and 48, which adds up to 51. We haven't found it yet. Now, is it divisible by 4? 14 by 4 is 3, and then 24 by 4 is 6. So that's the partner for 4 times 36, but this doesn't add up to 25. Keep this number in mind because that's our goal for the sum. All right, it's not divisible by 5, about by 6. We divide by 6 and we get 24. Now this adds up to 30. We're getting close, but we're not there yet. Now it's not divisible by 7. How about 8? All right, let's divide by 8. And we get 1 and 18. 8 plus 18 is 26. We're almost there, but it's still not the right sum. Now, can it be divided by 9? Let's try 9. So that becomes 1. 54. So 16. Looks like this is the one. 9 plus 16 is 25. All right, we got the right numbers. Now, the sign of the middle term is negative. So both of these must be negative. All right, now let's rewrite the middle term using these factors. So we're going to split negative 25a into negative 9a and negative 16a. And then just copy the last term, 12. We group the first two together. Now we group the last two together, but take note of this. Whenever you put a parenthesis after a negative sign, the sign inside must change. You have to reverse this. So that when you multiply negative, it's actually negative 1. Negative 1 times negative 12, you get back your positive 12. All right? So just remember that when you introduce a parenthesis after a negative sign, you have to change the sign inside. Now let's factor out the GCF for each group. So for the first, we have 3a. And then for a, minus 3. Right, that gives us 9a. Here we have the factor 4. That's the common factor. And then we get 4a minus 3. Now again, as in the previous problem, you'd notice that we have a common binomial which we can factor out. So we put these two terms together, 3a minus 4. We're actually just factoring out the binomial, right? Which is 4a minus 3. 4a minus 3. So it's done. We factored this expression. All right, now let's go to the third example. It will now be a bit different because the sign here will be minus. Okay. Now here's the problem. 6x squared plus 21x minus 12. Now, of course, you will have noticed that the third sign is now negative, which means when we break down the factors of the AC, we'll have to subtract the factors. All right, is there a GCF? That's the first thing that you always have to look for. You can factor out 3. All right, let's factor out 3 and write the remaining terms. 2x squared plus 7x minus 4. All right, now let's do the AC test. So AC will be equal to 2 times 4. 2 times 4. You don't have to consider the sign at this point. We'll just worry about the signs later. So we don't have too many things in our head. Just worry about the numbers. So 2 times 4 is 8. And this is what we factor. Now our goal is to get a difference. This time we're looking for a difference, not a sum, because this is a minus sign. We're looking for a difference of 7. Looks like we already got it. 8 minus 1 is 7. So we can now rewrite the middle term. Now, so that we don't forget the GCF, I'm going to use a bracket so that, because we'll be using parentheses. That's the reason why we need a bracket. So we have 2x squared. Now we rewrite 7x using these two terms. By the way, we haven't distributed the sign yet. Whenever you do subtraction, the signs will be opposite. It's not like before where the signs are the same. Here it will be opposite. The sign of the middle term goes with a bigger number. So 8 will be positive and 1 will be negative. All right. Well, let's do that. I'm going to write 1x, even though it's not necessary to put a 1. All right. It's not necessary to do that. Now, for the second group, we have 8x. All right, see, 8x minus 1x will still give you 7x. Minus 4. We don't have to change the sign inside because this is a plus sign. If it were minus, then we have to change this. Now, let's factor out the GCF from each group. So for the first, it's just an x that we have to bring out. And we'll be left with 2x minus 1. All right. Now, if I didn't write the 1 here, you might think there's nothing here. There is a 1 there. All right. So make sure that you leave a 1 in case you didn't write anything here. There's still a 1. Now, for the second group, our Our GCF is 4. So we write a 4. And then 8x becomes 2x. And 4 becomes 1. Alright. Now, again, you'll notice we have a common binomial which we can factor out, and we combine these two together. Alright, so our factors will be 3, x plus 4, and the common binomial, which is 2x minus 1. So there, those are the factors of the original trinomial. Alright, we have one more to go, and then we're done for this demo. Now for the last one, we're going to use an expression which has minus in both the middle and the last term. So we have 6x squared minus 5x minus 6. So these are now both minus. First, let's check for a GCF. There's none, so we go straight to the AC test. We multiply A and C, that's 6 times 6. And that will give us 36. So we're looking for factors of 36 whose difference is 5. Right, that's not the one. Divide by 2, 18. The difference is 16, so that's not the one either. 3 and 12, with the difference is 9, so it's not the one. 4 and 9. 9 minus 4 is 5. So this is the pair that we're looking for. Let's distribute the sign first before we forget. The sign of the middle term goes with a bigger number, so this becomes negative 9 and this becomes positive 4. Alright, we now have to rewrite the original problem. 6x squared. And then we split negative 5x into plus 4x minus 9x minus 6. By the way, it doesn't matter which one you write first. Alright, you can interchange the positions of 4x and negative 9x in these problems. They will give you the same factors in the end. Alright, now let's group the first two together, the last two together. But again, let me point out there's a negative sign here. Alright, where you introduce the parentheses. Therefore, the sign of the last term must be changed to plus. You have to reverse this. If it's minus, you make it plus. If it's plus, you make it minus. So that when you distribute negative 1 to that, you get back your original number. Alright, we can now factor the GCF for each pair. For the first, we got 2x, leaving us with 3x for the first term. And the second term is simply 2. We do the same for the second pair. Let's factor out 3. That's the common factor. And then we get 3x plus 2. So again, you'll notice you have a common binomial. So we can combine this with that. So we have 2x minus 3 and 3x plus 2. So if you apply FOIL on these factors, you should get back the original. You won't do that anymore, but that's what should happen when you multiply the binomials. All right, so we've covered the 4 types. Let's go back to the 4 types again. So in the first, you have both pluses. So the middle term and the last term are both plus. So when you apply the AC test, you have to add the factors. In the second one, you have minus and a plus. Since the third term is a plus, again, you have to add up the factors, but this time the signs are both negative. For the third one, we have a minus and a plus here. So if the third sign is minus, you get the difference of the factors, and then you distribute the sign of the middle term. The bigger one gets the sign of the middle term here, and the other one gets the opposite sign. And in the last case, we have 2 minuses. So again, we have to do subtraction. We get the difference of the factors in order to come up with a middle term. And then the sign of the middle term goes with the bigger of the 2 factors. The other gets the positive sign. So that's it for factoring type 2 general quadratic trinomials.